we're Group 25 and we'll be talking about our project SonicScribe.
So our goal was to make learning and reading music more accessible to everyone. We wanted to allow everyone to learn how to play their favorite songs on the piano or whatever instrument whenever they want. SonicScribe is an audio transcriber, meaning it will convert music files into legible sheet music. This transcription process serves multiple purposes. By transcribing music, individuals can easily learn to play their favorite songs on various instruments. With sheet music readily available, aspiring musicians can follow along and practice at their own pace. Transcription also aids in understanding the intricate structure of music. It allows enthusiasts to delve deeper into the composition, identifying chord progressions, melodies, harmonies, and other elements that make up a piece. Additionally, transcribing music can inspire creativity and serve as a foundation for composing original pieces. Leveraging machine learning models, we were able to transcribe music files. These models were enable automatic music transcription, which allows it to analyze audio recordings and generate accurate sheet music automatically. This eliminates the need for manual transcription, making the process faster and more efficient. So how it works is SonicScribe will either take an MP3 file or a WAV file as the input, and then you can choose on how to make your model. So there are two different methods you can choose to transcribe your music from. You can choose to run it with the onsets and frames model or the HFT transformer model. These two methods will be described later in the presentation. After converting the music, you'll be left with a MIDI file and your sheet music.
All right, so on top of SonicScribe being a music to sheet music transcription service, it is also an all-in-one music hub with many features. Some of the core features include an account webpage, which allows users to upload their songs and view the songs they have stored on their account. Through the account page, they can choose to retitle their uploaded song to a new name and also choose to public or private their songs, allowing other people to be able to search for their song if they want. These songs then get stored in the database, which allows other users to search for a specific song depending on the song visibility the user chose. If the user later decides they want their song they uploaded to instead be private or public, they can click on the song at any time to change it in their account page. Users can also choose to favorite their songs, allowing them to access it quicker by searching to the Favorites tab. On top of the search and upload functionalities, users can also view resources where they can access links for various tutorials and courses for reading sheet music and how to read music in general. In the resources webpage, users will find there's also a list of articles and guides for reading music at their disposal. And if the other options aren't the user's cup of tea, there are also video links for them to learn to read music and learn various rhythm patterns. On top of the other functionalities, there's also an interactive piano game in which a user can connect their digital keyboard, allowing the user to play along with the song to improve their piano and music skills. SonicScribe has been designed to be a comprehensive music hub, really allowing users to store and search for songs with ease, opening the world of music to many.
So in terms of technologies, we decided to go with MySQL as our database to store our music records and their associated XML files. We decided on SQL since it was familiar for the group and provided necessary structure and querying capabilities needed for this project as compared to a alternative like NoSQL MongoDB. Firebase was chosen for user authentication as it provided a very simple and effective microservice for our use case. For the front end, we decided to go with React and Gatsby as its component-based architecture was familiar and easy for the group to implement and collaborate on. Our choice of backend framework was Express.js because of its simplicity and its similarity to the front end's reliance on JavaScript and Node.js. This made the developing process much simpler and hassle-free as compared to choosing a backend framework in Java like Spring Boot. Finally, additional technologies such as Python, TensorFlow.js, and PyTorch were required in the music transcription process to produce the desired output music sheets. MuseScore was also used for displaying the music sheets, as it was a great open source and free option as compared to designing a component ourselves from scratch for this purpose. So in the next slide, I'll talk about the uses of this project. So our project has a lot of real-life applications that can benefit millions of people worldwide. Individuals such as musicians are now able to quickly record their audio, upload it to our application, and receive back the music sheet. This is very beneficial to them as they can now use that sheet music for several purposes, such as practicing their songs or sharing it with fellow musicians. Audio engineers also benefit since they'll be able to create better music with this tool through a detailed visual aid that may spark new ideas. Individuals with hearing disabilities can also gain value from our project as they can now understand music with a visual music sheet. Many organizations and businesses such as music studios can use our tool as a learning aid for beginner musicians who are visual learners and would benefit from a visual aid of a music sheet. These studios can also quickly convert songs into music sheets through our technology instead of manually creating them like in the past with pen and paper. Other machine learning teams in the field of audio and music would also find this tool useful as it removes the complexity of converting audio to text and can save them the time of developing their own version of this tool. Finally, our tool can be offered as an API to other online music platforms who would value simple audio to text music sheet transcription for their applications.
So I'll quickly be going over a brief overview of the architecture we used. So our front end is built using React Gatsby, which provides out-of-the-box performance optimizations, such as prefetching resources and server-side rendering. These result in faster page loads, and this is particularly beneficial for an audio transcriber such as SonicScribe, where we want our users to expect quick responses and seamless integration. We also adopted a component-based architecture, which allows us as developers to work on the individual components in isolation, reducing the dependencies and potential conflicts. This leads to a more streamlined development process, especially beneficial in our team environment. Components can also be individually tested, making it easier to identify and fix issues. This contributes to the overall portability and stability of the application. To extend the functionality of our application, we leverage a wealth of native plugins like React Convo for renders and drawings and React Firebase for integrating login. These plugins help us in adding sophisticated features without compromising our performance. For the backend, we utilize an Express API server. Express is an easy API to set up, and it's also very easy to scale accordingly with our user demand. There's also access to many libraries to enhance functionality and ensure a robust application for all users. Express itself doesn't enforce a strict application structure, which allows the application to have tailored backends specifically for our use case. This flexibility is crucial for SonicScribe as it requires custom solutions for processing and storing data. Express's middleware architecture is a powerful feature for handling HTTP requests. It enables the easy addition of layers for authentication and error handling. This provides a secure and efficient backend infrastructure. Additionally, we've also chosen to deploy the front end and back end services independently. This approach promotes portability and allows us to scale or update our services without infecting the entirety of the application. MySQL is utilized and deployed independently as well. This ensures that our database can be scaled as needed while maintaining a seamless integration with our backend API, which supports our application's growing data needs. Lastly, our user authentication within our application is managed using Google Firebase. This not only provides a secure authentication mechanism, but also enhances the user experience by leveraging Firebase's robust infrastructure and security features.
So for our architecture diagram, we have divided into two components, which includes the front end and the back end. Inside the front end, we have the web server component. This component, as you can see on the diagram, serves as our front-end interface, which is built using React, Gatsby, HTML, and JavaScript. This is the interface that allows users to upload their audio files for transcription. To perform local transcription, TensorFlow.js is used to deploy the models into our site. Inside here, we use the onsets and frames models to automatically transcribe piano music and convert this data into MIDI format. The second component is the backend, and this consists of the API server and our authentication using Firebase. The API server is used to manage the data in the backend. In here, we use a MySQL database for storing the user's data. We make use of the Express API to handle multiple routes and endpoints. Within our Express API, we have different routes that perform different functionalities. The database routes handle CRUD operations on the database. Convert routes handle tasks like converting audio format files, as well as processing those files before sending them for transcription. The transcription routes handle the main transcription, which works with the HFT transformer. The HFT transformer is the component that is inside our Python environment and manages the transcription algorithm. We make use of Firebase to authenticate the user's email and password when logging in to allow users to easily manage their account. In terms of data flow and how the components communicate, the web server that consists of the websites and its features constantly work with the API server to process data for music transcription, which includes the database for storing user data, as well as authentication using Firebase. Using Express API, the routes created allow the site to constantly communicate with the database, perform file conversions, as well as interacting with the transcription process.
So now I'll talk a bit about how SonicScribe actually transcribes your audio. When you upload an audio file, SonicScribe first transforms it into a MEL spectrogram. This is a visual representation of the amplitude of each pitch or frequency in the audio file over time. This spectrogram is then divided into equal time segments and fed into one of our machine learning models. We have two models available, the onsets and frames model and the HFT transformer. The onsets and frames model uses a type of machine learning architecture called a bidirectional LSTM, which stands for long short-term memory. It runs on TensorFlow.js, which means it can operate directly on the client side in the browser. This approach reduces the load on our servers and allows users with slow internet connections to use our service without needing to transfer their audio files to our server. On the other hand, the HFT transformer model uses a transformer architecture. This model creates a better transcription than onsets and frames and delivers top-tier performance on the Maestro dataset, a popular collection of MIDI files used for piano transcription tasks. However, it requires a powerful GPU for processing, so it's only available remotely through our API. Both models output a prediction for whether each note is playing and how loud it is at a given time. These predictions are then used to create a MIDI file, which can be converted into any format the user needs. So next, we'll show you a demo of our actual application. Okay, this is the landing page for our application. It kind of just gives you a brief overview of everything our website can do and how you can use it. Now I'll pass it over to Horace to take over the transcription part.
So to start off, I'm going to go to the transcribe page. This is where the main functionality of our software is. The first thing you might notice is that we have a drop down for the two models. As mentioned in the presentation, the users are able to choose which algorithm suits them and their use case the best. So firstly, we have onsets and frames. This is locally hosted and a simpler algorithm, while the HFT transformer is a more robust algorithm and it does require an internet connection. We also have the question mark beside the algorithm to denote what it's based off, as well as the accuracy and type of performance you can expect from the algorithm. So what I'm going to do now, I'll just quickly upload an MP3 file. You can see that it accepts MP3 and WAV as well. It won't really accept any others. So I'm just going to hit convert really quickly, and then I'll pass it over to Gabe, and he can talk about the results page.
Once the user's audio file has finished being transcribed, they'll be brought to the results page. Here, they can see the transcribed audio as a MIDI piano roll or as a single staff. They can also view a preview of what the XML file will look like if they choose to download the XML. We also provide the ability for the users to download a MIDI file if they would prefer that format. Users can also play the audio to hear what it sounds like. In addition to these views, we also provide the user with our interactive piano game through the play along button. When the user clicks this, they'll be brought to the game page. From this page, we interact with the Web MIDI API to connect to a MIDI keyboard, like the one I have here. If I press a button on the keyboard, the notes will begin falling. The user is rewarded when they press a key at the correct time. Now, I'm not particularly good at piano, so If you press incorrect keys, your score will decrement. Once the song has finished playing, the user will be given a summary of their score and the ability to restart. Going back to the conversion page, if the user would like to convert a different audio file, they can press the Convert More button to be brought back to the transcribe screen, where their last transcribed file is available for them in the previous transcription section on the right. Clicking on one of these will bring them back to the results screen. The user's last 12 previous transcriptions are saved locally in their browser so they can access it again should they accidentally navigate away.
Thanks, Gabe. So initially, when we land on the search page, you can see every song that we have in our database. For now, we just have a temporary sheet music as a preview for every song, but later we will implement the actual sheet music to show on the actual preview of the song. So if I was to click on a song, we can see the actual sheet music being displayed. And then if you go back and if you want to search for a song, we use a substring search. So if I want to search for any song, let's say A Little Old Man, you can search for that and then the results will be displayed.
I'll be going over our resources page. So in here we have many links to YouTube videos, blogs, articles, and courses that can provide more educational information on how to actually read and use sheet music. These resources will help people to understand the utility of sheet music and how it eventually can help them learn an instrument and how they can use our application during that process. After that, I'd like to show you guys about our login functionality. So as you can see here, this is the login page where you would enter your email and your password. And we also have some abilities to reset password as well as sign up. So under the hood, we're using Firebase for our authentication. And I'll just take you guys through the process of signing up, logging in, and then I'll do a reset password. So the first step is to sign up. And in here, I'll enter my email. And the password. And I'll sign up. And now I'm logged in. So the next step, I'll just log out quickly and I'm going to reset my password. So I'll enter that same one again. And now I should get an email. So I'll just click the link and I'll enter my new password with just one extra character. And now I can go back and I'll log in.
All right, so once users are logged in on the web application, in the top right corner, they can click on their account, and here they can view their currently uploaded songs. They can also decide to search through them. So for example, chant, and the search results show chant. So if a user decides they want to upload a new song, they can click on the upload button in the top right corner. And here they can upload XML files, MXL, music XML. So for example, let's just upload sonic1.music XML. And then it pulls it up right here. And when you click on it, you can decide to either rename it or make it private or keep it public. And you can also choose to favorite it. For now, let's keep it Sonic1 public and save the changes. Now we can go to the search bar and type in Sonic1. And sure enough, it shows up Sonic1 in the search results. So let's go back to our account and decide to retitle it to Sonic2, for example. We'll keep it public for now and save changes. Let's go back to search and Sonic2, and it shows up. Let's say now a user decides they don't want anyone to see their music. So for example, Sonic2, let's click the checkbox and make it private and keep the name of Sonic2, save changes. And now when a user goes to search for it, it doesn't show up anything. So that's how the account page works.
Okay, so now I'll just quickly go over our database structure. So we only have one table, which is for the music records. So when we showed you that searching functionality, it's essentially just taking a substring from the front end, sending it to the Express backend, and then doing a SQL query on this table based on the column that is title. So we have a few columns in here, like the ID, the XML file, which is just the plain text file that we're actually displaying on the front end. We also have a user ID and a public Boolean field. So that would either be 0 or 1, depending on if it's public or not. And based on that is what you'll see on the search. So only the public ones will show up, unless you're looking at something that you own, of course. And yeah, I'll just pass it off to Sahej for the last part.
Finally, let's talk about the UI and interface. When designing our site, we made sure to create a clean and modern design that is easy for users to explore. The navigation bar at the top consists of clear buttons where users can navigate to their respective pages. If we go to the transcribe page, users are easily able to choose a model, upload their file, and see the results in an organized manner. For viewing the transcription, and to make it accessible for all users, we included the option to switch between different viewing formats for the transcriptions. Sheet music that has been transcribed can be accessed and downloaded with only a few clicks. Our goal is to make sure that music transcription is accessible and straightforward for musicians of all skill levels, and our website allows for this in a user-friendly and efficient manner. And that ends our demo. Thank you for listening.